Hey algebra students, welcome to today's lesson on describing functions. Before we begin, let's just review some vocab words that we were introduced to yesterday. Let's start off with domain. So the domain of a function refers to the set of all possible input values. When we're referring to input versus output values, the input values is referring to the x values. Okay, so again, domain is referring to the x values. Range is the set of all output values, which in this case would be the y values. Now think back to function notation. Well, the x values are just written as x. However, in function notation, the y values are written as f of x or g of x, q of x, right? The very first day we were introduced to function notation, we wrote that f of x equals y. So if I read this out loud, in other words, instead of saying f of x equals y, this says f of x is y. So see, f of x is the y. Check it out, right? So the y values you can write as f of x. Now remember, f is just the name of the function, but it could be any letter. F of x, g of x, m of x, q of x. All right, let's take a look at the first example. The domain and range of functions can be described using a compound inequality, which is two or more inequalities joined together. So think back to inequalities. They were these symbols, right? We reviewed them in the previous chapter. Those are inequalities. So a compound inequality just takes two of those and it puts them together. Think of when you have heard the word compound before, okay? So compound sentences in English, right, is when you take two sentences and you put them together. So for example, my dog's name is Barley. I can say Barley is a dog, period. Barley is male, period. Well, instead of writing those as separate sentences, I can say Barley is a male dog, right? So you like merge two sentences together, right? A compound sentence. You might have also seen the word compound in science, right? So water is a compound of hydrogen and oxygen, right? So H2O. So a compound inequality is just made up of two things, just like two or more things, just like a sentence or a compound when it comes to science. All right, so let's take a look at how we can write domain and range using compound inequalities for today. That's our goal. Below is a graph that we're going to take a look at. So it says, let's look at a guest's elevator ride. So this represents an elevator ride at the Four Quadrants Hotel. The graph shows h of t. So remember, this part, h of t, are the y values, right? So h of t represents the height of the elevator in meters, whereas t, which are the x values, are the seconds into the guest ride. So the length in time of the guest ride. All right, so let's review what we talked about yesterday with domain and range. Label the part of the graph that shows the domain of h of t. Okay, well, domain, again, guys, has to do with the x values. So we want to find out how far left and how far right, so how low and how high the x values or input values go. So as I look at my graph, I want to look left to right. So it's from 0 and then all the function reaches all the way to 15. So from 0 to 15. Okay, that's how you label the domain on the graph. You're looking on the x-axis, right? Domain has to do with x-axis. Okay, so how do we write that within a compound inequality? Check it out. They've kind of already set it up for you. So this is what a compound inequality, these are called and inequalities or conjunction inequalities. You always want to put the lower number first. So the lesser number first. So our lowest number here was 0. And your highest number for your function was 15 on the x-axis. Okay? So notice that the inequalities are both pointing left, and it says or equal to because we have exact points at 0 and 15. Okay? All right, next, label the part of the graph that shows the range. So the range has to do with the y values. Y values. So now I'm going to be looking at the how high and how low it goes, but you always want to look lowest to highest. Okay, so the lowest point here, right, is like at this height over here. You guys see this? Pew, 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 pew. I'm going to make it a little darker, right? So that's the lowest. So I'm going to kind of follow that all the way to -9. So you can kind of see, right? The lowest that the y value or the lowest point on the function has a y value of -9. What about the highest point? So like over here, right? The highest point goes all the way to 18. So we always want to kind of look at it low to high, especially since we're going to be writing these in compound inequalities. So again, these types of inequalities are called compound inequalities. And these are called and inequalities. For those, you always want to write the answers from lowest to highest. So the lowest y value is -9, the highest is 18. Okay, so let me just point out a couple things that you may not have noticed. When they talk about domain, remember, those are x values. Okay, so if you look at your graph, your x-axis represents t. So look what they used in the middle, right? If they're talking about x values, look at what the x-axis represents. That's t for time. But when they talked about range, we're talking about the y values, okay? And the y values are, look at how it's labeled on the graph. I'm going to show you over here, right? You see how it's h of t? So when you write your compound inequality, you need to make sure you use h of t, right? For the y values, let me use a different color here. Okay, for the y values, they use h of t. Okay, so for the x values, you use t in this case. For these, the y values, you use h of t because that's how the y-axis is labeled. Okay, this would be a good time to pause the video. If you are not understanding something, you could rewind or ask a question. When you're ready, you can go ahead and read the second example. Okay, so it looks like they want us to write a compound inequality to describe the domain and range of each function. Remember, a compound inequality, so we started mentioning it up here, a compound inequality is when you write two or more inequalities joined together. You've seen us a couple examples over here, right? Here's one of them. That's a compound inequality. You see the two inequality symbols. You see this guy. That's a compound inequality. So we're going to continue practicing that below. Okay. All right. So since they want us to talk about the domain and the range, I'm going to just take a second to label those on my graph. Especially for the first two, as I look below, that's all they want, the domain and the range, right, for f of x and g of x. Okay, so quick reminders. Domain refers to the x values. So I'm going to look on the x-axis, and I'm going to look for the farthest point on the left. Here it is. Farthest point on the right. Here it is. So I'm going to follow those to the x-axis. Follow those to the x-axis, and that's what the domain is, right? From here to here. Do you guys see that? Okay, so when I list the domain, I want to list the lowest value, which is, be careful because it's a little tricky. This guy's the one that's -5. This is the one that's +5. So if I count 1, 2, 3, 4, it goes from -4 to +4. Now, when I think of range, I should be looking at the y values, okay? So the y values. So if you look, the highest point is the same as the farthest left point. So that's the highest. And I'm going to follow that all the way to the y-axis. And then the lowest point is down here. Follow it to the y-axis. You see that? So this is the range right here. So the lowest y value, -3. Highest y value, 6. So just be careful because I know it's a little hard to see the 5s, right? Okay. All right, let's try the next one. Remember that domain has to do with the x values. Okay, so I'm going to look at the x-axis. Always label your x and y-axis, guys, if it helps, right? You want to make this as easy as you can on yourself. Okay, so because domain asks for the x values, I want to go from lowest to highest. So what's the farthest left, right? Because the low numbers are on the left. The point that's farthest left is this one. So I'm going to label that. I should start using color coding here. Okay, so the farthest left point and the farthest right point. The farthest point to the left and the farthest point to the right. And I'm going to just kind of follow that to the x-axis, right? So the domain is going to be from here to here, okay? So what values are those? I just realized I color-coded these wrong. I'm so sorry. I'm going to try to be more consistent I'm going to try to use red and pink for the domain values. Farthest left, farthest right. Follow it to the x-axis. So this is the domain. Okay. I'm just OCD sometimes. Okay, so that's -4 all the way to 5. Okay. So you want to ask yourself, how far left does it go? How far right does it go? Okay, next. Range is lowest to highest. So lowest to highest, right? Kind of see, look at the lowest point. So this is the lowest point. This is the highest point on the graph, low to high. So this marks the range, lowest to highest. So that's going to be, and again, sorry about the 5s, they're a little hard to see. So that's going to be -6. That's the low to the highest point, which has a y value of 3. Okay, so now let's take a look. And listen, guys, there's many ways to draw out your domain and your range. I've seen people mark it with like rectangles. So let me just kind of go back to this guy over here to just kind of give you an example of what some people do. Another way of looking at it is they kind of draw a box around the shape of the function, right? The lowest, that it captures the lowest and the highest. And they use that for the domain and the range. So the domain would be here to here and here to here. Okay? Do you guys see that? So there's multiple ways to do this. Again, here I am being OCD with my colors. Okay? That's another choice option for you. All right, let's take a look at the last example. So they want us to write a domain that would restrict this line. So remember, lines are infinite. So right now this line goes forever to the left and forever to the right, okay? We want to restrict the domain, right? Restrict means to like cut it so that the domain is from -3, 7 to 6, 1. So we're focusing in just on this chunk, okay? We don't want the domain to include all the other points that are on the line except for those. So what I'm going to do is I'm going to label my X values, because remember, domain has to do with X values. So I'm going to look at those and I'm going to say, okay, well, my domain for the X values is going to be between -3 and 6. Notice that -3 is more to the left than 6. So I'm going to say I want it to go from -3. You're going to do 2 of these less than inequalities. You're going to put X in the middle, another less than or equal to, right? There should be 2 of them. And then your biggest number um, goes at the end. So again, your 2 inequalities are both going to be less thans. That's for my domain, for the domain. Now range is asking you for the Y values. So now I'm going to look at these Y values and I'm going to say, okay, well, I want to restrict it. You can kind of see on the graph, the highest that it can go is 7. The lowest it can go is 1, right? So I want to say that this is the restriction for the range. But remember, you want to write it lowest to highest. So on the graph, you can see that the lower point is 6, 1. So we want to make sure we write 1 is less than or equal to. Remember, Y values are written like this, H of X, okay? So make sure you don't put X. X was for the domain. H of X is for the range, since that's asking for the Y values. And then less than or equal to 7. Okay, you'll get a chance to practice these a little more on your homework, but as always, if you need any help, don't be shy. Ask for help, okay? All right, guys, enjoy your day. See you soon. Bye.